Cool. All right. So hey everyone. So like we've been basically just yakking at you guys for 3 weeks now about like a bunch of concepts and like just showing you from our end how we did these things. But that's not ML. That's not data science. So like right now we're gonna start gently, right? It's not too much right now, but we're gonna build up to you guys being able to implement at least like a good chunk of this yourselves by the end of the semester in the project that we're gonna work on. This is an example. It's somewhat related. It's actually a little more difficult than the one that we have for you guys. So yep, I think we can get started. So how this is gonna work is first I have like a couple Zoom windows open. Are any of them covering the Google Colab? Only seeing Jazz. All right. All right. Let me reshare. All right. That makes sense. I had it open in a different window. That makes sense. Okay. Does that work now? Like you guys can see that now? All right, cool. So how this is gonna work is I'm gonna give you guys a link to this collab, this very collab, and it's gonna be view only. So you won't be able to modify this directly, but when you open it up and make sure you're logged in using your UMD Google accounts, your Terpmails or whatever. And when you open it up, I'll walk you through it, but I'll just give you guys like a minute to get it open. Just click on that and sign in using your UMD account. If anyone has any problems, just like, ping it in the chat or something. I feel like we can keep the Jazz running in the back. I'm gonna reshare with the whole computer screen. All right, let's keep the Jazz running in the back. Very faint. Okay. If anyone has any issues so far, just like say it in the chat. Otherwise, we can just keep going. So what Google Colab is, first of all, right? It is something called an IPy notebook, which means it chunks up the code, the Python code, into these things called code blocks or cells. And essentially, we can run each of these independent of the other cells. There will be errors if you try to, say, call a variable that you haven't defined yet, or if you're trying to import a function from a library that you haven't actually, imported at the top. And there's going to be issues like that. That's something that's easy to forget when we're doing, chunked up code blocks. But just remember, if there's an error, it's most likely because you need to rerun something before it. Yes, you should make your own copy. The instructions are up here, but we will read them out because user experience. You go to File, and you go to Save a Copy in Drive. And that's going to open up a file saying copy of BankChurners Part 1 at the top left. You can rename that if you want, but basically that's personal to you and your drive. It's going to be stored in your local drive and no one else can see or modify it. Once you guys do that, we're going to get started. Yes. I have what might be an important answer. How do you change it to dark theme? I believe it's in Tools, Settings. Yep. Okay. Go to Tools, Settings, Site, Theme, Dark. Okay. So moving forward, you just hit connect at the top. Okay. Because this is hosted on Google servers. I don't know. There's just something about light mode that's just too vanilla. So this is run on Google servers, and this isn't running on your local like laptop or computer like Jupyter Notebook would, but this is built on Jupyter, so it really functions in very similar ways. Right, so once you click connect, you should have this RAM and disk. That's how much you're stealing for free from Google. And yep, the problem, all right, and this is something that we introduced in the previous meeting, which is predicting what customers are going to leave. It's the same thing. We're just taking it a step further with an actual data set. Yeah, our brains, yeah, it's just something about light mode. But yeah, the data set can be found at this link. You can open it up. I actually have it open here. And this is Kaggle. It's a repository of a ton of data sets. People come up here to solve things, put them up. It's like a GitHub for data science in a way. So that's where we got the data from. You can actually scroll down here to this section called the Data Explorer, which gives you like a decent idea at first glance of what each column is, what each column means, most importantly, and some quick tiny distributions that we can do ourselves in more detail manually. But this is really useful in just getting a quick overview of what the data looks like. And that's going to be important in how we use it. So the first thing we want to do is manually import the data set. So you go to Kaggle, you hit download, all right? So you download the data set locally to your computer, and it should download as a zip file, extract whatever's in the zip file, and you should get a file called BankChurners.csv, or BankChurners, and then the file type will be a CSV. About, I don't know, a minute for everyone to do that. Okay, I can do that. Oops. Oh, actually, I can just resend the link instead of sharing it to an email, because if I share it to an email, I think you'll get the ability to edit it in real time. But we want this to be kind of, this one should be like view only for everyone, and then you can each edit it in a copy if you follow these instructions right here. Okay, moving forward. So assuming you have downloaded the data set, and if you haven't, that's okay, let me know. We can slow down. And you have it extracted and you have a file. It should be like, it should look like an Excel file called BankChurners.csv. You run the first cell, and it allows you to upload that data set into your Colab notebook for you to begin working, right? Let me drop the link again in the all chat. All right, so you can hit choose files, and you guys can see this thing, right? I go to where I have it saved, it's in documents, and I open it up. Voila, that's how it should look. It'll give you status of let's upload, and once it's done, you have it in your Colab file. You're ready to go. You can start your imports and everything. I'm gonna wait 15 seconds, and if we're all good to go, we will move forward. And like I know that some people are going to do it faster than others, but request everyone to bear with the group, the collective. Okay, so let's move forward. We have repeat importing it into Colab. You're making a Kaggle account. Okay, yeah. So you need to first download it. Okay, on this page, credit card customers, you can just hit download, and it's gonna get you a zip file, extract the data set from within the zip file on your local system, your laptop or whatever you have. And then you run the first cell in the Colab, which pops up as a little choose files button. Click that, and it'll upload onto your Colab. All right, cool, nice. All right, so we have it in our Colab, no problem. And we can run the next cell, which is a bunch of libraries, right? You hopefully have seen these names, at least a couple of them before. Pandas is what we're gonna use to manipulate our data set as a data frame object. That's just an Excel file almost. And we're not explicitly using NumPy, but we want to have it for more advanced things. We're not going to use it right now, but we're just having it in there for just to get used to seeing it, I guess. We're going to import Seaborn, which is a visualization library, and SNS, like, it's some sort of inside joke on, you can Google that. And then matplotlib.pyplot, that's going to help us modify our Seaborn visuals. Some people do the visuals in matplotlib itself, and that's totally fine, but Seaborn is just visually appealing, so we like to stick to it. All right, so the first thing we want to do here is import our data set into into a data frame using pandas. And there is a function for it. Does anyone in the chat want to write it out in the chat? We're going to do this together and make sure everyone does it themselves. Nice. All right, perfect. So we're going to do pandas. We did PD. That's how we imported pandas. And we're going to .read _CSV. All right, brackets, because it's a function, and the parameter that it takes is the name of the data set, and that's going to be BankChurners. Make sure you get the capitalization and everything correct. BankChurners.csv. All right, type that in double quotes, single quotes, whatever you want. Doesn't make a big difference. And we have df.head under it, and if you did that correctly, you should be able to see the data set, at least the first 5 rows of it, and each column name, and it's like very horizontally long, but don't worry about it. We're going to be chucking some of this stuff over time. If we are good to go, we have Kothari. Yeah, so in Python, this is passed in as a string, and because it's a string, we do need to have a single quote or a double quote around the name of the file within read CSV. The read CSV method, so yeah, PD is not really a class, it's a library. It's a bunch of functions designed to, I don't know the internal structure of it, but it's basically a bunch of functions designed to help us manipulate the data. So yeah, it does belong to the pandas library. Okay, so the next step, we have the data set imported, and we need to do some data cleaning because data is almost always filthy. That's just the real world. In the data set that we have for you guys, we have planned for you guys in the project, there's not that much cleaning to do, thankfully, because that one was nicely designed, but this one is pretty dirty. So what we're gonna do, and if someone knows what a Bayes classifier is, awesome, but we don't need the last 2 columns, which is basically another model's prediction on this data set. We don't want that. We want to treat this as a logistic regression problem. So we're going to chuck those, just run this next cell. Don't type anything into it, just run it as it is, which is going to do df.drop and then the Bayes classifier column names. All right, moving ahead. For our purposes, we just want to be clear on what our target is. What is our target with this problem? We want to check, or we want to predict if someone has left the credit card, bank, has left that bank as a customer. And that's why we want to be specific and changing the attrition flag to the word label, just for our understanding. Attrition flag is located right here. It is the second column in the data frame, and we're just going to rename it to label. The next thing we want to do is swap it so that attrition flag is at the front, and we're swapping it with client num. So what we need to do here is df_swap, and we need to type in a thing there using tf.reindex. This one might be a little hard to recall, but df.reindex columns is the parameter that we're passing in. We have a list of columns here, which we generated out of the data frame, all right? And that's just a list saying client num, attrition flag, customer age, so on. And we did a little switcheroo. We said 1 is 0, 0 is 1. We just swapped the 2 places because indexing starts from 0 in Python. And we have a swapped list of columns, and we just need to pass that in to df.reindex. And we're going to save that in this new variable called df_swap. And that went well. Yep, there we go. So label has moved to the front of the data set, the data frame, and client num is now the next element. All right, so again, df.reindex columns is equal to this list that we made, pre-made list called calls, where we swapped the first and the 0th elements, which are these two columns. If you guys want me to slow down or speed up, let me know. All right, so this cell just does a little description of the overall data frame. It gives us the last 5 as well, last 5 values as well. And you can see, I guess most importantly for our purposes, would be the size of this data frame. The number of rows represents the number of actual data points, the number of customers information that we have in our data set. And the number of columns will be the attributes, all of these things labeled, the client number, the customer age, gender, so on, all the information that we actually have. And that's df_swap.describe. So now, if anyone can recall, if not, that's okay. In 15 seconds, how do we print out the type of data in each column in Pandas? It's really short, it's one line. All right, no problem. Describe, no, not quite. Dtypes, yes. Describe was what we used up here to get an overall picture of the data frame, but we don't have the type of data listed in describe. So we use dtypes, data types. So we do, our variable was called df_swap, SWP, and we just add dtypes right there. Run that. Now you get a list of each column name and the type of data that's stored within it. All right. So we have object, which in this case is just a string, right? Because label said existing customer or attrited customer, and that's stored as a string in the data frame. Client number is an integer, 64-bit int. Object would be another string. And then we have some floats at the end. Float is just a floating point, a decimal. And 64-bit means it's double precision because normal floats at 32. This is all computer system stuff, flashbacks. But yeah, so the next thing would be to make a copy and store it in a new variable, df_clean. This is just to modularize the changes that we make so that we don't need to go back to square one if we mess up at a certain step. So does anyone know how to copy or make a copy of a data frame? It's a really intuitive piece of code. Yep. All right. df_swap.copy, and this we're calling it as a function with no parameters. I missed parameters in describe. I mean, I think it can be done either way. Let me try it with the. That looks so much nicer. Thanks, Shanil. Yeah. Thank you. Oops. That's what describe should look like. My bad. Parentheses should go in here. And now we have a few stats about it. What was the re-indexing? So what re-index does is it basically switches values in, or okay, how should I put this? In the data frame, we have a list of all the columns, right? And they're in successive order. This is column 0, column 1, column 2, column 3, so on. And we just wanted to switch from here. We wanted to put attrition flag at the front. So that's why we wanted to re-index the data frame with a new list of columns where these two were swapped. Does that make any sense? Why are there parentheses around some methods and not around others? Shanil, do you know the answer to that? I'm not very familiar with that. I'm just
some methods are like configured to take in values. So if you want something specific, like you can pass a value. So for df head, for example, you can pass the number of columns, number of rows you want to display. And some methods are written without any input parameters. So in the methods which are meant for parameters, we have empty brackets, but we can use to fill it up though.
Okay, thank you. So if the method has no like parameter, then you can't put a bracket, or can you still put a bracket and it'll still work?
I don't think it will work if you put brackets.
Okay, thank you.
Grammar and spelling are important. But if you want to
All
write
right, sorry.
essays that inspire,
But there we go. And another thing is, if we don't include the parentheses, I think it also in some cases it returns an object. Like in D types, we can't add the parentheses and have it do the thing, right? So it's an object, and we need to put it out in the notebook. All right. So yeah, again, object, int 64 and float 64, the three distinct types in this. Yes, almost everything is case sensitive in Python, so you have to be really specific with the case, all the things. Okay, we are going to we made the copy of df underscore swap, and we're storing it in df underscore clean. And let's just take a look at this just to make sure that we have our new data frame copy. Now, what we need to do is drop the missing values, all right? And what I mean by missing values is we have some rows which have at least one value saying unknown, right? Marital status, unknown for this customer. How do we get around that? There's multiple ways to do it, and it's called null value treatment and so on and so forth. Shanil mentioned it a couple of weeks ago, and it's the process of addressing missing values. And there's multiple ways to do it. The most direct and quick and dirty way to do it would be to delete a row that has unknown in it, or NA or NaN or null, or just a blank cell. Any of those just count as missing values. So that's what we're going to do, but there's other ways to handle them, including, adding in the median of the data set for that value, like just replacing it with a equivalent placeholder. But we don't want to do that because we know too little about the source of the data, and we don't want to jump to conclusions about it. So, and we have the data to spare. There's 10,000 entries, so we can just drop anything that says unknown. How do we do that? Iteration, a for loop. It's technically a for each loop because it's like for I in, we need something there. And this is what I need you guys to figure out with me together. Essentially what we need is a list of columns. Not exactly. We cannot iterate directly over the data frame for this purpose. We need to get a list of only the columns in df underscore clean. Anyone have any idea as to how we can just get only a list of all the columns? Just indexing over this. Iter call, is that a thing? I'm not sure. It sounds like a thing. There we go. Oops, I should add the there. All right, it's df underscore clean dot columns, and it returns a shape of an array of size 21 columns in it. And what we're doing over each column is we're going to drop a row if that column contains the value unknown. Does that make sense? We're going over each column and then checking in that column if there exists an unknown, like in this marital status, we have an unknown. Then we're going to drop all of row 3. It's very brute force, but it does the job when we have a ton of data. Okay. If you guys have any sort of questions or anything, just stop me. But yep. Oops, there's a problem. What did I do wrong? Need to refer to the solved example. Shh. Don't tell anyone. Oh, that's what I forgot. Okay. In Python, we need to add a colon to iterate. All right. There we go. And now if you look at the serial numbers here, you can see we're missing row number 3, which had an unknown in here. And under metal status, that unknown is no longer there. We only have 0, 1, 2, 4, 5, and throughout the rest of the data set, anything that had an unknown value got deleted. Boom, done, gone, wiped off the face of the earth. Now we need one line of code to inspect the new shape after having deleted all the unknown rows. We need to inspect the shape. Does anyone know how to? Not quite df.inspect. There's another one. The keyword is here. Yeah. So df clean.shape. All right. And that is going to give us the new number of rows, which is 7,000. It jumped down there from 10,000 or something before. And we still have the 21 columns because we didn't modify the columns. All right. Now there's 2 broad types of data in here, right? One is categorical, things like education level, right? High school is a category, graduate is a category, uneducated is another category. Similarly, we have income categories, this range, this range, this range, so on. And what we need to do is our machine learning model doesn't know how to process strings, doesn't know how to process anything that isn't a number. So we need to encode the values in it. Whichever ones aren't already numbers, we need to encode them into numbers so that we can feed it into a model. There's multiple ways to do it. There's cooler ones like one-hot encoding, but you don't need to worry about that unless you want to talk about it later. We need to give a number to each category. So like the next 2 cells will be about how to do that. First, what we want to do is in each categorical column, and we can, figure out which columns are categorical, which ones aren't, from the D types that we called here, right? We have anything that says object, you can guess it's a category because it's not an int, it's not a float in this case. So we want to get all the unique values in each of those columns. Why is it so quiet? Where's the, is it? Can you guys hear that? All right. Okay. That's a lot nicer now. All right. We have each of these categorical columns. Sorry for the interruption. And we need to get the unique values in each one. All right. Running for these 4, you can see we have under label, there's 2 possible values we can get, right? Existing customer and attrited customer. Under gender, there's 2 possible values, male and female. Education level, we have all of these. Marital status, these 3 things. Now, what we need is for you guys to similarly do this for these 2 categories, income category and card category. Just follow along whatever's up here and put it in. I'm gonna wait about 30 seconds and then do it. I am gonna assume that 30 seconds have passed. But anyway, you can just copy these last 2 and then change whatever. This is for our purpose. We want to make it clear what we're putting out. So income category. Yeah, not having to put a semicolon at the end. It's legendary. Python is GOAT. Put income category there, and we want the card category. And we're basically saying within df underscore clean, we're getting out the card category column and then printing out the unique values in each whatever, like column. You are happy that functions have parentheses again. Yeah, OCaml is pretzels turned into code. Okay, the next step is to make an encoding for each of those categories, right? So we have male and female, for instance, for gender, and we want to assign that 1 and 2, or whatever order you want. It doesn't make a difference at the end. We have to go by some order. Do you need me to go over something again, Rishi's? Everything cool? You got it? Okay. All right. So we've done most of them. Label has been given. And remember, this is a dictionary. It's a dictionary of dictionaries. And you can see the format here, very clearly specified that it's the key is going to be the name of the column that we're going to encode. And then the value of that key is going to be another dictionary, a mini internal dictionary that has each current value name, whatever it is right now, existing customer is a value name, and then the value that we want to encode it to. So if we want to give 0 and 1, or if 1 and 2, 1, 2, 3, 4, what I would recommend is in the label, stick to 0 and 1. And make 1 the target variable, like what you're trying to predict should be the 1. Here, you're trying to identify if someone left. So if they leave, give that a value of 1, true, like whatever Boolean expression makes you happy. But yeah, it needs to be a number. The other ones, I would not recommend giving a 0 because, it doesn't make a huge difference, but just because these are going to be actual numbers that go into the processing by the model. And if you multiply by 0, the weight doesn't really have any effect, no matter what weight the model sets it to. So just, it's nicer to avoid the zeros, even though it won't make a massive difference. But in the label, we do want to have a 0 and 1, because logistic regression, if you remember the sigmoid curve, it basically has to give an output between 0 and 1. And we essentially round that to either 0 or 1. Right, so we need to encode this last one, card category. So card category had 4 distinct values. We had blue, gold, silver, platinum. Ascending order of shiny, so blue, silver, gold, and then platinum. Let's get that in here. Let's pick one where we need to do least effort. Card underscore category. And we had blue, let's make that 1. Silver, gold, and oops, let me get, how do we get it with the comma there? And the last entry in this mini dictionary within the outer dictionary should be platinum. All right, just look at the overall structure of it. It's a dictionary with a bunch of dictionaries within it. So that's the key, and then the value is another dictionary. So if anyone wants me to stop here or something, let me know. Not stop, but pause here. Let me know. Let's see, keep track of the time. 6:06. We're almost done with this part, and then Shanil's gonna walk us through data exploration, which is like the actual colorful stuff. Can we move forward to the next 2 steps? Yep. All right, cool. So we have our categories. All our categorical variables have been converted to numerical well, they haven't been converted yet, but we need to run this next cell to do it. And that calls this function called .replace, which swaps out the old the category names and then puts it in with the new values. Variable names, puts it in with the new values. My tongue's all over the place, I'm sorry. But there we go. If you look at the data now, oh no. Why does card category still say blue? Oh, I haven't done this. Okay, running it again. Card category now says 1. There we go. There's no more strings left in here. It's all numbers, all ints and floats, and that's perfect for the model to actually process. A final check. Have we actually encoded all our data? How do we do this? How do we check the data types? We've done this a little while ago up top. Yes, okay. Perfect. So we've saved this replaced version, this encoded version, and a new data frame just for that modularity of code under df underscore enc encoded. So we're gonna do that dot d types and run it. There we go. Everything's an int or a float, and that's it. Any questions up to this point? Because after this, it's going to be like the next phase of this, which is data exploration. All right, I'm gonna assume that looks like things are moving pretty well. Shanil, it is 6:09, and exactly 21 minutes for you. Do you want me to keep the screen up here, or do you want to share it from your end, or how do you want to do it?
Yeah,
I
you
can run it.
keep the screen up.
Okay.
Because then otherwise I have to fill the entire thing again.
Yeah. Sure. So I'm gonna mute my mic, and you just tell me when you want me to run the cell and whatever else you want me to do.
Yeah. Okay, so we can start with the data exploration part. Rohit will run the first cell, and which is a count plot. So we see how the data set is skewed. So in this case, most of the customers are not attrited, while some are. So that's what we can see with the 0 and 1 count plot. And the next one is...
Wait, Shannon, 1 second. Before you go to the next one, I just wanted to add in the balance of the data set is really important in machine learning because it affects how well your model can learn. If you give it data that's mostly unattrited, then it's going to have a higher error rate in detecting the ones that did leave, as opposed to if you had a more balanced number of each. But yeah, sorry.
Yeah, next is the heat map. We even saw this like last time. So in a heat map, I can just explain it again. So you basically take a label. Rohit, can you scroll down a bit? Just a bit more. Oh wait, this is a huge one. So we basically take each column and correlate it with like other columns, like all the other columns. So if you see label versus label, which is 1, which is obvious because they are the same column. But if we do something like, let's say, income category versus the fourth column down, which is gender, which is like a negative correlation, yeah, that's how the data set is skewed. But if we do something like total transaction amount versus total transaction count, which is on the bottom right, the 0.81. So in this, it's pretty obvious that, okay, so once the number of transactions go up, the amount will also go up. So, and with this, we can find the columns which are correlated. And if we have like highly correlated columns, then it can cause the model to train on that and like, yeah, and then cause issues while predicting the the real thing, and it will give us false positives and false negatives. Yeah, that's the written description of it. And generally we do something like we classify for each data set. So it's almost always around 0.8. So if the correlation is above 0.8, we would probably want to convert those columns, or in this case we can probably do like amount per transaction because we have the ability to do so. But if we cannot, we can drop those columns if we have enough possibilities. This is one more count plot of a customer age versus the count. So, and count is our label. So this is the plot for like attrition versus the age. So we see like most customers are in the middle age group, and like as the number of customers also increase, the attrited customers increase. Yeah, and we have a box plot for the same thing where we can also see uh, outliers. So like for this specific box plot, we have outliers which are above the age of approximately 65 in this. So those customers generally stay in the bank and they don't attrite, while most people in the range of less than 30 to more than 65 generally are attriting. But the maximum number of people attriting will be between 40 to 50.
And that also says something about how this data might have been collected, right? Most of the customers that might have given their information, or the bank would have taken the information from through these processes and transactions, uh, most of those people would probably be in their 40s and 50s, because that's where most people would want to secure their financial stability for themselves, for their families, and that also speaks to how the data was collected and not just the tendency of the actual customer. It's a combination of both factors.
So this is a very interesting count plot. Even while we were going through this, we were shocked by seeing most customers in this bank are exactly 36 months old, like 3 years old. So
What?
this
No, no,
also
no,
tells us,
no. The accounts are 3 years old, not the
yeah,
people.
like yeah, like they are like 3-year-old customers in the, yeah, the accounts are 3 years old. Better. Yeah. So we can assume that the bank collected this data and filtered out for long, like mostly long-term clients. Yes, it looks for the column name within the data set. So the last parameters data equals to the data frame. And within the data frame, it will try to look for each column. And once it finds those columns, it will plot. And if it doesn't, it will give you an error.
Don't worry about this for this project, but if you do want to look up the Seaborn documentation and learn the library, there's great courses out there on data visualization and stuff. You could do that, or you could just use a tool like Tableau or even Excel, which can allow you to draw pivot tables and pivot charts that allow you to do some degree of visualization.
Yeah. So this is the plot for number of relationships versus for each like for customers. So once they have a higher number of accounts, for example, so then we can see the trend of if they attrite or if they probably want to stay. So if we see the attrition is maximum when there are like 2 to 3 number of relationships, and it goes down when you have more number of accounts, as you would want to stay in the bank if you trust them with having 6 different accounts. And this is the box plot of label versus the total revolving balance. And people with higher balances generally stay, and the ones with like variable balance to the median or mean generally are the ones who are willing to attrite.
Yeah, and if you're ever confused, guys, about what a column or what a category or whatever thing means, go back. If you pulled it from Kaggle, you will have this again, Data Explorer, and you can look up what that was. This is the total relationship count. That means the number of products held by the customer. And the one we just looked at was the total revolving balance, which means, to my knowledge, it should be the credit limit, but we can check that. Oh no, credit limit is another thing. Okay, revolving balance probably has a meaning in terms of credit. If anyone's like a finance student or something, they should be ashamed of me. Yeah. Shanil, any other final notes before I wrap things up?
So if you all want to like view more of Seaborn or something, I had put resources in the slides of the introduction to data science meeting. So you can see documentation on Seaborn and how to make your own plots and what parameters to put in. And there were also like a bunch of different plots in the Colab file for that one. If you all want to view like different plots and not something similar, but so in this meeting and this example, we can see how we can actually use these visualizations to understand how the data is queued and what we can do with it. And if we want to change something, so if they're outliers, we probably want to remove them. If they're like highly correlated columns, we can probably adjust them or remove them.
All right, cool. Thanks, Shanil. So that's essentially the data exploration part of it. So again, data cleaning was an initial bunch of processing that we wanted to do so that we could standardize the format of the data, so that we could swap around the columns as we needed, and address missing values, and just make it, like very satisfying as mathematicians slash statisticians. But then we went to data exploration, where, as Shanil talked about, we're basically trying to understand what the data is showing us. As a human, we're going to look at some visualizations, draw some inferences. And sometimes people stop there. They don't need to go any further than that because you already have a bunch of business insights. Things like if you go to the revolving balance, people with the lower revolving balance have been known to leave. So maybe as a suggestion to the bank, if you were doing this as a consulting project, or data science advising, data analysis advising project, then you would tell the bank, hey, maybe loosen up on your total revolving balance or your credit limit or whatever else you want to let them do, or let them know as an option so that they can keep more customers. And sometimes that's enough. Sometimes we need something more technical, which would be given an actual customer, we need to know with a certain degree of certainty whether they're going to leave. And for that, we bring in the power of machine learning. And to do that, there's another step that we're going to explore next week called feature engineering. And then we're going to actually, go through the process of building a model. It's really abstracted. Don't expect like a really complicated, cool, under the hood type of thing yet, because initially we wanted to focus more on the data stuff. But later in the semester, maybe if we have a week or two to spare, we can do a manual model building routine. But for now, we're going to leave you with this cliffhanger. And next week, we are going to talk about feature engineering and building the model. Officially, we're done. If you have any questions, if you want me to summarize anything, if you want to ask Shanil anything, fire away. One-hot encoding. Okay, awesome. So one-hot encoding is a process of creating a new vector for each categorical variable. What that means is, suppose we had, where did we print out the value? We had a bunch of print statements. There we go. Right? So suppose we had gender. Let's take a simple one. There's two values in here. In real life, there's a lot more. This data set is what it is. Sorry about it. But essentially, there's two variables there. we could create a vector to indicate someone was male, someone was female by saying 1 0 for male and 0 1 for female. Right, so it's oh yeah, there is a feedback form. Thanks so much for reminding me. I actually made it right before starting the recording. Let me share that with you fine people. Shorten the URL. All right, please fill that up. Thanks so much for reminding me. Yep. So if we had two values, right, male, female, we will get a vector for male that says 1 0 and a vector for female that says 0 1. And that kind of helps make these values orthogonal in a linear algebra sense, so that you're treating them as completely different from one another. The problem with this kind of encoding is, which we're giving it values of 1, 2, 3, 4, 5, 6. We're implicitly placing some sort of order on that data. We're making it almost ordinal, even though it might not be, right? In the case of blue, silver, gold, platinum, it kind of is, but in gender, in education level, in metal set, none of those things can be ordered per se. So we use something like one-hot encoding as an alternative way to encode that data, so that we don't treat it as relevant in a certain order. The vector 0 1 would be perpendicular to 1 0 in the real squared space. Did that make any sense? Did I just go on about nothing? Yeah, it's basically, that's that's kind of like binary, what you just put up there. I'm talking about vectors. So suppose male would be 1 0. It's a square bracket. It's a vector with two values, and assume that's vertical. Female would be 0 1 as another vector, which is perpendicular to the male vector, so that they're treated as independent of one another. The human monkey brain ruins the purpose of encoding, so we make a solution that's non-biased. It's somewhat like that. It serves two purposes in that way, if you think about it. One is to be fair to all categories and not order them, and the second is be more accurate when giving it into the model, feeding the data into the model. So for the map, what do the values represent? Yeah, plus is a positive and negative minus is a negative correlation. How are the values calculated? Shanil, any insights on how these correlation numbers are created? I know there's a way to calculate it, like using a scatter plot, but I don't know how this does it. Shanil, are you Earth to Shanil? All right, let's look it up. How are heat map correlations calculated? If we can't find the answer really quick, then we can definitely look into this later, but abstraction has made us lazy. That's a good thing and a bad thing. How much depends on the absolute value. I don't know. How I would intuitively think about it would be a scatter plot. If you look at a scatter plot that compares two variables, right? Let's take a negative one. And you have a bunch of data points and a variable on each axis. If you have one variable increasing and one decreasing, and if you wanted to see by how much, then you look at the slope of the line that you would use to approximate this. All right, thank you guys. Thank you for coming. Take care. See you next week. We have part 2 of this coming up. But yeah, I can stop the recording. 1 second. Stop recording.